Okay, in this tutorial I'm going to show you how to use the solver in Excel to solve linear programming problems. I'm going to illustrate it with this problem right here. Sampson Smith Incorporated sells two popular brands of cookies, Sampson's Sugar Cookies and Rebecca's Raisin Cookies. Sampson's Sugar Cookies go through the mixing and baking departments, and Rebecca's Raisin Cookie, a filled cookie, goes through the mixing, filling, and baking departments. Michael Frito, Vice President for Sales, believes that at the current price, Sampson Smith can sell all of its daily production of Sampson's Sugar Cookies and Rebecca's Raisin Cookies. Both cookies are made in batches of 3,000. In each department, the time required per batch and the total time available each day are summarized below. Revenue and cost data for each type of cookie are also summarized below. In this box right here, we've got the given information. So in this table right here, we've got the two types of cookies, sugar and raisin, and the amount of minutes that are required for each type of cookie in three different departments: mixing, filling, and baking. So, for example, to make one batch of sugar cookies, it requires 30 minutes in the mixing department, 0 minutes in the filling department, and 10 minutes in the baking department. This bottom row indicates that the total minutes available per day in the mixing department are 660, 270 minutes are available in the filling department, and 300 minutes are available in the baking department. And then, down here we have the revenue and cost information for each type of cookie. So for sugar cookies, the revenue per batch is $475, the variable cost per batch is $175, and the contribution margin per batch is therefore $300. There are also monthly fixed costs of $18,650 that are traceable directly to the sugar cookies. Similar information is provided for the raisin cookies. Now that's the given information, and what I've laid out down here is how you can set up the problem in Excel and then use the solver to help you find it. So our objective function is basically just written out right here. We want to maximize the contribution margin associated with making sugar and raisin cookies, the total contribution margin. Okay, so that's going to be equal to this $300 per batch of sugar cookies times the number of sugar cookies plus $250 per batch of raisin cookies times the number of batches of raisin cookies. So what we have to decide to do is determine how many batches of each type of cookie to make. So I've got this table right here that I will use, and I've highlighted these cells blue to indicate that these are the cells that these are our decision variables. This is what we need to change. Then I've got the calculation of my objective function. So the calculation for this objective function is that I'm going to calculate the total contribution margin from S, which means sugar cookies, as well as the total contribution from R, which is the raisin cookies. So for example, if I put 1 in here, meaning I'm going to make one batch of sugar cookies, you can see that the contribution margin for sugar cookies goes up to 300, and the total contribution margin for the company goes up to 300 also. If I add one batch of raisin cookies, then the contribution margin for raisin cookies goes up to $250, and the total contribution margin goes up to $550, 300 plus 250. Alright, so these cells, if you pay attention to up here, what's in the formula bar, this cell is the product of the contribution margin per batch of sugar cookies times the number of batches of sugar cookies that we're going to make. This cell is analogous to the one that I just looked at, and then this total contribution margin is the sum of the contribution margin from sugars and raisins. Alright, so you can see that I formatted the blue cells, the ones that I need to change, and the yellow cells are the ones that will be affected by the blue cells and that we'll want to use in the solver. Okay, now this next table down here is a table to lay out the constraints. So the way this works is that I've got a row for each constraint. How many minutes in the mixing, filling, and baking departments. There's only a certain amount of minutes in each of those departments. And then each column right here, I've got two columns, and these columns represent the number of minutes that will be required for each batch of sugar cookies and each batch of raisin cookies. So this 30 right here is equal to the number of minutes that a batch of sugar cookies requires in the mixing department. You can see it's just equal to B11. This 0 right here is equal to the number of minutes that each batch of sugar cookies requires in the filling department. And this 10 right here is equal to the number of minutes each batch of sugar cookies requires in the baking department. And then similar information for the raisin cookies. So these cells are just referencing the original data up here. And that's always a good idea, to keep the original data in its own place where it will not be influenced by other calculations. Alright, then in this column right here we've got the total minutes. So you can see if I double click on this, that this column is going to be equal to, and it's a sum product. You could use the sum product function in Excel if you want, but here's a way that might be easier to understand initially. And so what we're going to do is we're going to say, if we make one batch of sugar cookies and it requires 30 minutes per batch, and that's 30 minutes of time required in the mixing department, and then one batch of raisin cookies times 15 minutes per batch is another 15 minutes, so the total is 45 minutes. All right, let me just change these back to 0 so that you can see what it starts at. All right, so if I have 0 there, the total minutes that will be used are 0. If I decide to make one batch of sugar cookies, then what will happen is I'll require 30 minutes in the mixing department, no minutes in the filling department, and 10 minutes in the baking department. And if I increase the number of batches of raisin cookies up to 1, then each of these numbers goes up by 15 because these are all 15 right here in this column. Alright. Now in these cells right here, these are just placeholders to help remind me what my constraints are. And again, the constraints are that I've only got a total amount of minutes of 660 available in the mixing department. So this number right here has to be less than or equal to 660. I've only got a total of 270 minutes available in the filling department and 300 minutes available in the baking department. All right, so these less than or equal to signs are just a reminder for what I need to plug into the solver. Now, to plug in the solver, you'll need to go to the Excel options. So this is Excel 2010. It'll be a little different in Excel 2013, but if you go to Options, and then Add-ins, and then down here to the bottom, Manage Excel Add-ins, hit Go, and you can see I've already checked the solver add-in. Then you hit OK, and what that will do is in this Data ribbon, over on the far right, in the Analysis portion, there's a solver button. So I'm going to click on that now. Okay, now the solver starts out as it's a wizard, and so it kind of walks you through what you need to do. And it's saying set your objective. So it's just saying what cell is your objective function, or what are you trying to really maximize or minimize. And so in our case, we want to maximize this cell right here, the total contribution margin. So that's cell D29. Then we choose if we're trying to maximize it, minimize it, or get it equal to a particular value. So we just want to maximize it. And we're going to maximize it by changing these cells right here, the number of batches of each type of cookie. Alright, and then it's subject to certain constraints that we've laid out here. So the first constraint that I'm going to add in is that this cell right here has to be less than or equal to, and that's the default option that it gives you. So I don't have to change anything there, but you can see that it is possible to change something to equal, greater than or equal to an integer, binary, or diff. I don't even know what that means yet. And the constraint means what does it have to be less than or equal to, and that's going to be this cell right here. Alright, then I'll hit Add to add in a new constraint. This new constraint is that this filling department total minutes has to be less than or equal to constraint right there, 270 minutes. One more constraint is that the total number of minutes in the baking department has to be less than or equal to that cell right there, the 300 minutes. And I hit OK. And then just use the rest as it is. We don't need to worry about the other options at this point. And you hit Solve. And it tells us that the solver found a solution. Everything is satisfied. We want to keep the solver solution. And Just hit OK, and it tells us that the optimal number of batches, given our constraints and the contribution margin per batch, is 18 batches of sugar cookies and 8 batches of raisin cookies. So that's an example of how to use the solver in this problem right here, the Sampson sugar cookies.